Alright, time for another DraftPhysics.com video presentation, debatephysics.com also, where there are a bunch of 5-minute videos explaining different conundrums or paradoxes, you could say, in physics surrounding energy and the distinction between kinetic energy and momentum. Now, I am defending the theory that momentum is elemental. It's how the universe entirely functions. It's about masses moving velocities, and there's no 1/2 or any squared function. It doesn't take 25 times the fuel to go 5 times faster. Just a fact. And so in attempting to defend momentum and point out that kinetic energy just creates a bunch of fake particles, fake physics, because it creates a bunch of fake energy. It means that light things going fast have somehow more energy. That 5-ton trains going 10 miles an hour have twice the energy of 10-ton trains going 5 miles an hour. When logically, no. If they actually crash them or they do the tug of war, you're not going to find that the 5-ton train has any more capacity to move metal than the 10-ton train going 5. That momentum is all that matters, and momentum is essentially weight. Anyway, so that's the argument, and there's good reason to believe, because there's good reason not to believe it takes 25 times the fuel to go 5 times faster. So until they can fix that, they really can't fix any of it. So the Ian Gosling just keeps arguing away from the points being made. So we're talking about catapults and how they function. The on the record fact is that we found that the reality isn't the idealization. So if you had a perfect lever, yeah, you could do lots of experiments where you could dissect this momentum issue very easily, but we don't have the idealization. So levers are made out of a substance or material, and the catapult in this case. And in this case, we're using a spring to provide the energy, and you're going to launch objects. And the simple argument being made is that, yes, the lever absorbs part of the energy. So the spring has to move this lever. It is a real material thing, and it has to be moved to move the other objects. The transfer device has to be accounted for. In this case, the transfer device weighs 1/3, okay, the mass, all right, of one of the objects you're trying to launch. And the simple argument is therefore it's consuming, okay, a high percentage, 1/3 of the energy the spring is producing. So instead of the energy going into the object, it ends up going into moving the lever. Now the trick is, as you move something further out on the lever consumes a lower percentage. So with a 2 mass here and a 1 mass here, as pointed out, it's 1/3 of this mass, but it's only what was it, 2/5? Oh shit. 1/5. I can't remember. Anyway, well, 1/3 you can figure it out. It's 1/3 of this. This is twice the momentum, so it's yeah, I still should be able to figure that out. It weighs 1/3. It weighs 1/2 of this weight. That's it. So that's why it's 1/3. This has 2 portions. This only has 1 portion, 1/3. So it weighs. So in the case of the 2 mass, it has the 2 mass would have 4, and this would have 1. So that's 1/4. The total is 5, so it's 1/5. Okay, so it's 1/5 of the mass. And the idea is you have to get these two to be equal if you're going to have a fair contest in terms of putting the energy into the object. You want the lever to consume the same amount of energy. Obviously, the faster the lever moves, the more energy it's consuming. And you want those two numbers to be the same amount so that the objects are getting the same portion of the energy. So if you're looking for, if you're going to say this lever is going to consume a percentage, you want it to be the same percentage. So you know, it's like, let's say it was 75% of the energy you wanted to go into the objects. Both of them have to get 75% for it to be a fair contest. If one of them's getting 85% and the other one's getting 75%, then it's not a fair contest. So the simple way to do that is to make less momentum go into the lever. So even though it's 1/3 the mass of this object, that is 1/3 of the amount being moved, you can make it less momentum by just moving the object further out. Now, I said in a video, the last video, I said, oh, maybe it's 2.5 or maybe 2.3. Okay, yeah, no, maybe it's 4.7. All right, I was just making numbers up. Okay, sorry you took those way too seriously. The point is that there is a point where it's diminishing returns, where you're not going to get any higher velocity. But the clear indication is the further out you put any object, the faster it goes, the higher percentage of the energy it gets, because the lever moves less. That's the simple truth. To get a big movement out here, I just need a little movement here. So that's the trick, is that you can make the lever move less by putting something further and further out. Therefore, the lever will take less of the energy. And so I made this argument now 4 times, and he doesn't understand the argument, and that's the problem. He doesn't get it. Okay, so he says that in a previous video he did it from like somewhere around 8 inches. Okay, so this was 3 inches here, and this was more than double. Okay, 8. I don't think it was quite 8, but whatever. And the truth is, though, that was before he had done his fixing. That is, he took this part of the lever off and he put a little thing on here to make it possible to make good contact. So he's making much better contact. So that experiment, even though that experiment did produce exactly what I'm claiming, in the sense that you got more kinetic energy than you were supposed to, which means you're on the road. Okay, so the 2 mass object went here, and the other object went here, which is more than 1.5. All right, so it was closer to 1 point something else, a higher number. Clearly indicating that, yes, you were starting to realize that faster velocity, and you just need to go further out. Simple answer. And all of this happens only because, yes, he's using a very heavy lever. So the heavier the lever, the more energy it's dampening out of the contest between the 2 objects, and it's doing it unevenly, because clearly the heavier mass is a bigger portion of the total matter that has to be moved. You have to count all of the matter inside the lever and the object. And you can clearly understand that, yes, something that weighs twice as much mass is going to be a higher percentage of the total mass being moved. So the lever can't move at the same speed, or the lighter object is going to get ripped off. Alright, it's going to get a lower percentage of the energy, the total energy. Alright, so that's the 4th, at least, maybe the 5th time I've explained it. And he just keeps doing this crap instead of just doing the experiment. And I said, he doesn't have to do these experiments, it's fine. If he wants to claim that he's proving or debunking, he calls this DraftScience complete debunk. He's not going to completely debunk anything. So it's all this exaggeration. They take this unfinished crap and they make these huge claims about how they've proven something, and they haven't come close to their obligation. So you can see in this image, it has a critical flaw right in the image. I had suggested that he needs, alright, so I'll draw this. You know, I really shouldn't even have to. But he just doesn't follow along very well. And look, it's physics. You know, all of this stuff there's a lot to it. It's a little bit complicated, so yeah. But they want to make 35-second videos on the subject. They don't explain anything, they can't draw anything, so, you know, they're all crippled in that sense. So what he did on his own, and it was a very good idea, because the lever moves more, the center where the object is actually going to hang is going to be different. This one's going to be a lot further, and you're going to have to hit it instead of push it. So his simple solution for the lighter mass that's going to move more distance from the lever, more velocity, was to put a little stump on here. So now when the lever's pulled back, they both objects rest on the lever. They're actually in contact, resting on the lever, so they get pushed. So that was an improvement. Now what I said in my video was, well, you should do something similar, synthesize a same hitting surface for the other side. What I meant was, you just put a little tiny block here, little tiny one. So it's the same surface that's hitting, it's the same size surface, the same mechanism. Clearly in this image here, he's got a big giant block here. Okay, that wasn't the idea, because yeah, that completely pushes the other thing forward. That's no good. You lose your center of mass, all of that crap happens. So that's a disadvantage, not an advantage. So not a great idea. But what it also demonstrates is maybe you need something that also has more of a dimension to it in the up and down direction, because as the thing lifts, this is why a longer lever would help. I mean, probably is better off doing this on the floor, from the ceiling to the floor, because the longer your lever, the less these are issues, the less problem they're creating. But the problem is as it swings, it lifts up. Okay, so when you're pushing it, the problem is your pusher is going straight and the object's lifting up. So in a sense, it might be better to have a pusher that's a little higher, because then at least you get rid of some of that. It's also pushing sideways, which is another problem, but I'm just saying you can only fix so much of it. But clearly the fact that it raises up above the piece of wood he put on there is a little bit of a problem. The center of mass ends up going up, and as the center of mass goes up, it goes over the edge of the thing pushing, so it can't push anymore. So yeah, it's good that he thought of that, and but he has to take it a step further, and he's going to complain about that apparently. Yeah. But whatever, again, it's, if you're going to do the experiments, then try to do your best and do them. But there's no point in griping about it. You're either interested or you're not. I think these are all experiments that clearly should have been done by physics. We shouldn't have to rig these things together with pieces of wood. This all should be done professionally and well. And it's tragic that you can't agree with that simple statement. I mean, that's the real awful, disgusting part of this whole conversation, is that these people don't think these experiments should have been done, and they don't think they should be done very well.
Hello guys. We all like a paradox, don't we? I'm going to get to that in a minute. I apologise if this might be a bit of a rambling video. I've got to get my thoughts out on.
I only listened to the first 5 minutes, and then I said, well, I can't listen to this twice. So it's just ragged bullshit again. You can't perform in any other way than to just do all of this nonsense that he throws in.
And I'll try and get him.
Just get to the stinking point.
In one of your later videos, I think it was yesterday, Gary, you were talking about this lever. Before I get to the paradox, this is a little aperitif, if you like. You're talking about this lever, the one.
So you can see this big giant piece of wood he put here. I didn't suggest a big giant piece of wood be put there. I just suggested that you make the contact points for both objects as the same as possible. And yes, the difference in the distance between the objects is a fact, and you should compensate for that. So having this one longer than this one makes perfectly good sense. I wouldn't stop doing that, but I guess I'd obviously have pieces of wood you could move that aren't glued on. So maybe better to drill holes through the wood, and then you can poke a screw through and have the screw hit the thing, some other kind of mechanism. But whatever. You engineer it your own way, fine. Oh, I have to turn that. I knew there was a good reason to check. There was a good reason to check. All right, so you can see here, you put a big block of wood here. No, that's not what I suggested. I suggested just a little thin one that was the same dimensions as the one pushing the other object. You want everything to be as same as possible, accounting for the differences based on the fact that your lever weighs too much.
Distance and the two distance. If we alter that ratio, we can fix the problem, you said. We can get...
Yeah, I'm saying that, yeah, as you pointed out, as we both, I think, it was demonstrated to us that on a catapult, it really doesn't matter very specifically where you put the weights, because there is, I mean, I drew this part too. The lever's here, right? It's unlike the experiment where you're putting the mass in here and pushing the mass over here. Unlike that experiment, there's no risk of something bouncing, and there's no risk of something going through. The spring is producing the energy, and it's always going to produce all the energy it has, and it's going to put it into the lever with whatever mass you have on it. So no matter where I put the two mass, it goes pretty far. And the fact is, the further out I put it, the further it goes. And what I'm clearly arguing is, if you put the one mass the right distance away to make those fractions the same, that is the percentage of the lever's movement, that the percentage that the lever is moving. If you get the lever to move the same speed for both objects, then the percentages will be the same, and if you get the percentages the same, then the lighter mass will be going twice as far as the heavier mass. It's just you have to move it out further to accomplish that.
Nearer to the 4 times the height with the half mass. And I noted what you said, 1 to 2.5 or 1 to 2.
Yeah, so you noted what I said. Now in a little while you're going to say, I almost did it from 4. No, you didn't. You almost did it from 3 times, not 4 times. So I could take what you say, I can make a video, I could make a video, Iron Gosling completely debunked, because you said 4 when you should have said 3. So the fact that he took these numbers so damn seriously is just retarded. It's just nonsense. I clearly in the video was just making them up. I was just saying it has to be further out.
2.3, something like that. We'll fix the problem.
The fact is, it will fix the problem. You already found that out. You already demonstrated it. You already didn't demonstrate it goes faster the further out you put it. And the point is the two mass will stop going faster, and the one mass, as you keep putting it out further, will keep going faster and faster for a much further distance, and it will eventually go twice as fast. And that's the fact. I'm arguing is a fact. That if you put it out far enough, it will go twice as fast with the same spring energy.
I've already done that experiment.
So he hasn't done that experiment. So blah blah blah.
This is the lever, this is the spring, this is the fulcrum, this is the one distance, which measures 3 on this scale, 3.
He could just play his own video, right? But I guess he can't play a video. I saw the video. I mean, I think I played it, actually. I could show you the clips, but yeah, it is 1.6. It's not 1.4. Well, it's not 1.5. It doesn't go just twice as high. It goes twice as high plus, okay, which is clearly indicating, well, that's too much kinetic energy. So we know the kinetic energy thing isn't doing well, and yes, it's not 4 times as fast, but I'm just saying it's getting there, and the further out you go, the faster it's going to go.
Divisions. This would be the 2 distance, 1 mass and a half mass. I'm not quite sure where the 2.5 would be.
Yeah, so again, I should have said maybe it has to be 2 to 3 or 2 to 4. So I shouldn't have said 1 to 2.4. So yeah, I made a mistake in terms of, yeah, that's not enough of a difference. You can't make up for the 1/5 to 1/3 thing. You can't fix that with just that minor amount of distance change.
But let's say I did a 1 to 3, which would be here. A 1 to 3 would be 1 distance, 1 mass.
Times 9. Okay, 9. 1 to 3 would be 9.
2, 3 half mass. I went even further than that.
So he's got a drawing here, right? The 8 is this end line here, right? So I mean, he's obviously 1 to 3 would be 9 inches, 9, 9, 9. So unless 8 is here, I don't know. He doesn't have a mark here, so who the hell knows what he's talking about?
I went out to here. It was an 8.
So again, he says this is 8, and then he says 1 to 3 is here short of 8. Well, 1 to 3 isn't short of 8. 3 3s is 9. Okay, yeah.
So 3.
2 3s are 6. 3 3s are 9. 4 3s would be 12.
3 distances to 8. One more little division out here would have been 1 to 4.
So he just said that, right? So that's wrong. It wouldn't be 1 to 4. Going 9 inches would be 1 to 3. It wouldn't be 1 to 4. There, you made a mistake. Oh dear. Let's make a video about it and say, look, you are completely wrong in everything you say because you said 1 to 4. I mean, this is just so childish. You're such a jerk.
1 to 4. So I did a little bit short of 1 to 4. So this is 1 to 3. Quite a bit more.
So again, it isn't 1 to 3. Okay, if this is 8 inches, this is not 1 to 3 because it's less than 9.
1 to 3, and we didn't get anywhere approaching your 4 times the height. So it's disingenuous again for you to.
Okay, and we got way too much kinetic energy. So again, the fact is that yes, you're well short of the twice the velocity. I'll concede, but you're way well over. Your kinetic energy conservation as well.
Say, why don't I do that? I've done that. You skipped over it. Go and find it.
I didn't skip over it, and it was done before you fixed this lever. That is, you made these modifications that made a clear difference in how it performed. And so the argument is if you leave in the fixes you made to the lever and do it again, your results are going to be different, more dramatic.
Watch it. Well over your 2 to 5.
Well over 1.5. It goes more than twice the height. So anything more than twice the height means your theory's in trouble also.
Or 1 to 2.5, 1 to 2.3. I nearly did a 1 to 4.
So he said it again, okay? So he's saying made the same mistake twice. So yeah, I guess I can make 2 debunking videos because you said this. You made the same stupid statement twice. You didn't go anywhere near 1 to 4. 1 to 4 would be 12 inches, shit for brain. You didn't go anywhere near there.
Nowhere near it still. So go and find that. Watch it again.
Watch your own video. You just fucked up, jackass. So this is where I stopped.
I'm sorry guys if I sound a bit agitated. I'd like to be all love and light, but it's irritating a lot of this business. Now, Gary's paradox. I've got a feeling this is probably one of the most important videos I've done so far.
Oh, this will be ridiculous then. His understanding of physics is so bad that this will be ridiculous.
On this subject. And obviously you're going to watch this, Gary, but whether you play it through on your channel, I don't know.
Oh, well, please. Jesus. Hilarious.
If you do watch it, when you get to your channel, you've already attacked it to the point where you can twist everything and skip over everything. You don't listen, you don't get it. But genuinely, from my heart.
You clearly don't listen. You've had 4 days now, or 3 days, to redo the experiment better, to film it better, to do all these things better, and you haven't bothered. Instead, you're trying to reclamate shit. All right, instead of improving what you're doing and showing us all what would be nice to see revealed. I mean, I just got this little Newton's cradle, $1.50, right? And what I found, which was very curious, right, is I put my finger here as a stop. Look what happens. Nothing. Absolutely nothing. No reflection. All right, and my finger doesn't seem all of that rubbery, but apparently it's rubbery enough, right? And all I have to do is put a piece of metal instead of my finger, something metal. Let's see if I can do that. I mean, I'm really trying to, I didn't plan on doing this, so this isn't a great plan. So I put a piece of metal there, and then you watch the difference. Well, that didn't work. It's not a good enough piece of metal. It needs to be denser. All right, here's a toenail clipper. Let's see how that does. So, now, there. See the bounce? See the bounce? Look how much more bounce you get. So, it makes this huge difference how, how solid this thing really is. And you can be fooled that something's solid, but it really isn't as solid as you think, and it's going to absorb a huge, all of the energy, essentially, is going to be absorbed in a bunch of little motion. So these are facts, that you learn. Shit for brains. So we've learned something about catapults, that it's not as simple as the idealization.
This is where you're created a paradox, which I'm sure, if you thought long enough about it, you have to concede you're wrong, and you do like thinking about things. Where you're going wrong with this colliding the masses business. It is a funny one. It's easy to make a mistake. I probably looked at it and confused myself thinking about it. But with clarity of thought, logic and reason, listening, thinking.
Oh, please, whatever. Just he's going to try to reclamate creating free momentum and then destroying the free momentum. There's no way you can reclamate that. There's no way you're going to make sense out of it. Okay, you can't make free energy in any form, kinetic energy or momentum, and then say I destroyed it just as quickly. It's so anti-physics. It's flat earthy. It needs extraordinary evidence. It's an extraordinary claim, that you can just make energy poof away, that it doesn't turn into heat, or it doesn't go somewhere, that it isn't leaking out of a system somewhere. The very idea that you can just poof it in and out of existence is just, it's anti-physics, frankly. It's anti-everything physics is about. Are we still? Yeah, it's videoing. Okay, well, I'll take a pause. Alright, I'm back. Continuing.
Zip it up. Zip your mouth up. You will understand it. And I'm not going to attack you like you do to me if I've made an honest mistake.
Oh, fuck you. Just fuck you and that bullshit. What a fucking lie. Jesus Christ. That's all these videos are, is attack videos. Jesus Christ.
I've come on here and I've apologised and said, I'll hold my hands up. You can't do that.
Oh, bullshit. Where did that happen? You still haven't apologized for the fraud of hiding the clay experiment and coming up with a non-excuse for why it didn't come out your way.
It's your modus operandi to keep going on the attack and bringing things up. And while we're at it, one of the mistakes that I made in measuring the heights to drop masses from, you've gone on and on and on about it.
Yeah, because you covered up the experiment. Fuck, you made a video saying proof based on an idiotic mistake you made, okay? And you called the video a proof, and you made a stupid, a 1+1 kind of fucking idiotic mistake. It was so stupid a mistake, all right? Then you corrected it, did the experiment, and the results came out perfectly consistent with what I argue, and you didn't show that experiment. You didn't have to debunk your own experiment. You didn't show it. You didn't have to debunk it. You just said, oh, something went wrong. It didn't come out my way. That was it. And then you, as a duplicitous hypocrite, accuse me of that crime. You fuck. What a piece of shit you are. Oh, amazing.
Now I can't be trusted for making such a silly mistake. But we're going to get to your...
That's not what I said. But again, I have pointed out your fucking exaggerated titles are just that, lies. You just lie in the title of the videos even. So yeah, how much character or honesty can a person have when they sit there and call something a proof, don't even take the video down, don't retract it, don't do a goddamn thing except sit there and double down on it and say, well, it came out his way, so something must be wrong. Let's come up with some new rig or some new gadget that'll give us the results we want. And then you accuse somebody else of doing that. Amazing bullshit.
Paradox in a minute. And God knows what I would say about you, or anybody would, for the mistake you're making. But I'm not going to. I'm going to leave that in your realm. But going back to this, we'll get to it in a...
We've seen your realm. Again, the title of this video speaks for itself. DraftScience Complete Debunk. What has he debunked so far? Nothing.
Another video, but I believe that not just was I wrong, but you are also wrong. I had the weights above the line or below the line, and corrected me, I had to put them above the line. I believe that is wrong. And we'll get to that in another video. So when that...
So he's going to keep arguing old bad videos. Videos that are kind of not perfectly filmed and not perfectly done. He's going to keep arguing that old crap instead of just redoing it better.
That is shown as wrong. What am I going to do? Can you keep going about how stupid you are? Shall I do that?
No, what you should do, what I should do, I guess, is just keep replaying. You're doing the experiment while you're doing a song and dance while you're doing it, and your results are coming out with 30% differences from one experiment to the next. You got a huge error, in a huge inconsistency in how fast the thing leaves when you're doing exactly the same experiment. Should come out pretty much exactly the same way. You shouldn't have a huge variation in how it comes out.
Yeah. No, we'll see, but we'll get to that later on. This is now Gary's paradox.
So where has he gotten to anything here? So 5 minutes into the video, there's not even anywhere close to anything on the subject.
And I think I've been over this before, and we're going to go over it again.
Oh, how exciting.
And forgive me for my drawings, they're a bit naff and a bit rubbish. I didn't put too much effort into them because I'm short of time, frustrated, one thing and another.
I don't know. It's not even that you put effort into them. They don't even write on its face. This one isn't going to make any sense. But anyway, go ahead.
But excited, because this is a complete debunk of bad thinking, bad logic,
whatever.
Bad reason.
Yeah, right.
So I'm helping you.
Oh, yeah.
You're not going to pay me for it. God knows what.
Is it going to get to it? No.
Cost you for someone to pay a professional.
Oh, whatever. I mean, this is insufferable baby talk.
We'll put you back on track with your thinking. Oh, it's worth a lot of money, I would think. We've got one mass coming along from left to right. And you can keep talking over this, and you will.
I'll just keep pointing out how it's not Newton, Descartes, or Galileo's physics. So what you're arguing is some physics they didn't see. Somehow it's so magical and fantastic that even though they did thousands of experiments, frankly, you could even include Huygens. Huygens didn't even find this.
Deal with it honestly. Do yourself a big favour. One mass coming along left to right. It's got 10 velocity. Let's put that into energy. 1 times 10 is 10. Let's call it joules because joules is energy. 10 joules, right?
I don't know. Is it 10 joules? Aren't you supposed to be squaring something and having something? So I guess when you're using the number 1, you're always sort of in a little bit of trouble squaring because, yeah, it's not going to mean anything. So if it's a one object, somehow it has half the number of joules and the momentum would be 10. But the joules would be half 10. Oh, it's 10 velocity, sorry. So, yeah, well, I don't know what you're saying here. So, 10 velocity is going to be 100, and 1/2 of 100 is 50. So it should be 50 joules. So I don't know, you didn't even get this right.
This is what you say, isn't it? Momentum is energy.
I don't say momentum is measured in joules. I said that you have to multiply it by a number. Now I can't remember whether the number was 3 or can't remember what the number was, but yeah, you just increase it by a number. So you take the momentum and you'll get an approximation of the joules if you want joules. I mean, a newton is 1/10 of a joule, just as a fact. So you can do the conversion.
We're dealing with the energy now. 1 mass, 10 velocity, 10 joules. Right, Gary? So if this...
So no, I didn't argue that. I said it's 10 momentums. I'm happy using the word momentum and saying it's 10 momentums. That works for me fine.
Mass come along here, knocked in some pins, as you put it, bowling pins, it knocked all 10 over. 1 joule a pin. We've done that work. Knocked 10 pins over. 10
whatever. Get to it.
joules of energy. Right, Gary? Up here again, left to right. We're going to drop another 1 mass on here, onto this mess. We forget what energy it took to drop, lift, and down collision. Let's make it a perfect conjoining. What should we call this action?
God, I think he's really stupid. I mean, he really thinks that there isn't, that physics doesn't argue that it loses half the kinetic energy, because physics does argue that. That's what they overtly say, all of them. Physics Michael will say it, Physics Girl said it. They all believe it lost half its kinetic energy.
This is I can't remember the word, pre-joining. I don't want to use collision because you'll start saying, no, there's always energy loss with a collision, so let's not say that.
I mean, the experiment's been done. I mean, it's not that complicated. Okay, the ticker tape. It's a famous ticker tape. They use the ticker tape for whatever reason to measure the velocity. It's a very accurate way to measure velocity, but I mean, whatever. So it's a very old experiment, been done for decades and decades and decades. And the fact is you add the extra mass, you allow gravity to combine the two, and the cart remains contains 99% of its momentum. So after the event, it has the same momentum and half the velocity because it's doubled the mass. So it's a perfect conservation of momentum experiment. And it's really a lousy kinetic energy experiment because it basically says you lose half the kinetic energy and there's no evidence you lost it to anything.
Joining. Pre-joining, one mass dropped onto that is the joining, and then they go along together. Okay? Now, as you say, you now got half the velocity, 2 mass, you've got the 10 joules. Same momentum, same energy. 10 pins it would knock over, the 2 masses would knock over 10 pins. So far, so good. I'm sure there's a danger here. It's so simple, and yet a lot of people won't follow it. I apologise for that. It's a fault of mine.
Oh, okay. So he's going to do something that a lot of people won't be able to follow. So he's predicting that his explanation is going to be too silly for even the average person to accept.
I'm not explaining it clearly. This is so simple. We're not going to use any mathematics other than 2 plus 2, which is 5, of course. Now, Gary, this mass coming along here, what energy have you had to put to get that mass moving along? Somebody had to put some energy in there, haven't they, Gary? Well,
yeah, it's irrelevant. It has momentum, and the argument is that the momentum is conserved as it should be, because no other work was done. Nothing was melted, nothing blew up, nothing broke in half, none of the energy disappeared anywhere. It's still in the system, and you're just transferring it from one object to a bigger object, and that's all you've done.
Let's say you did. Well, let's say it cost you 10 joules. Is that right, Gary? It's cost you 10 joules to get that mass up to the 10.
Momentum, yes. It takes momentum to cause momentum. So, yes, to give it 10 momentums, you had to hit it with something that had 10 momentums to give.
And velocity. And when it hits the pins, we get 10 joules back. Impossible, of course. There'd always be some loss. But let's pretend it's a perfect transfer.
Well, the fact is that transfers are almost perfect because you are using gravity when you drop it. You're using gravity to combine it, so you're not having to use any energy to smash the weights together, so to speak.
Action of energy. This is an energy account. This has got the 10 joules. When this, do you agree that it always costs, and there's always an energy cost to moving a mass? I think this is where you're going to try and weasel out of this, and nobody can support you.
I hit it with something. I hit it with a 1 mass going 10 velocity, and it's a steel. It's elastic. So I hit it with something that had 10 momentums, and now this thing has the 10 momentums. What's complicated? Oh, that's right, nothing.
Insane. You don't have to have an energy cost to move a mass. We're not talking about nature doing it or God. We're talking about us accelerating or moving this mass up to a 10 v velocity. There's an energy cost to whoever does it, whether it's nature or God. Same we're doing it. You've got to put in energy, haven't you? There's going to be a cost to move that mass.
That's what conservation of energy is saying. The cost is exactly what you end up with as a product. And if you didn't get the whole product, if I throw dollar bills at somebody, right? I throw $10 at them. They might catch 9 of them and they'll miss 1 of them. Well, that's a lost dollar, but it's not lost. I mean, it's going to be picked up by somebody. It's going to go somewhere. The whole argument about conservation of energy, and I could quote Feynman, I can quote a lot of physicists, regular physicists. I mean, you have to conserve it. There's no energy poofing.
So, when this one's dropped on, gravity is dropping it in a vertical. That's perpendicular to the direction it's moving. It's moving to the right. There must be an energy cost.
No, gravity is giving you energy. It's adding energy to the system. It's not subtracting energy from the system. The gravitational energy is more motion. More motion is being added. Okay, there's no motion being subtracted.
To accelerate?
It's like when you throw something in gravity, right? I mean, the gravity doesn't subtract from its motion this way unless it's on frictional surface, or unless you're pushing it into the ground. If you're just throwing it in space, it's not going to have any effect at all on its gravitational influence. So it's going to keep orbiting for hundreds or thousands or millions of years, like the Earth is doing.
Or to move that mass up to its 5 velocity. Do you agree? It doesn't matter whether you agree or not.
No, I don't agree it takes any more energy than the energy it's sacrificed. It's losing momentum in the sense that, I mean, it's losing velocity. It's losing 5 miles and it's giving the 5 miles an hour velocity to the other object. It's just exchanging the velocities. What's so complicated? Well, absolutely nothing's complicated here. I can't believe he calls this a debunk. Oh, anyway, time for my dinner. So till the later, I will get to this. I should be back and continuing. Not much to go on here, so I don't think he's going to do anything shocking.
We're going to prove.
I guess, well, since it's not much left, we'll put the volume down a little bit.
Logic that you're talking about a fallacy, this paradox.
It's not even a paradox. I mean, it's just your physics. It's inevitable. You can't change the result. I mean, if you take energy and put it into a heavier object, it's going to reduce the velocity. The reduction in the velocity means a huge reduction in the energy because of the squared function. So you can never conserve the momentum and conserve the kinetic energy in any one of these experiments where, you know, the momentum is still moving in the same direction, where you can't use your little subtraction trick.
Once it's dropped on and they're conjoined and they move off at 5 velocity, there has to have been an energy cost.
Yeah, I think you already did this before, and then you realized, oh yeah, well the 5 mass is going from 10 miles an hour to 5 miles an hour. That means that's the cost. It's lost 5 miles an hour, but it gave it to an equal mass, so the momentum is perfectly conserved. But the kinetic energy, you lost half of it in the process somehow, without losing any momentum. So you lost half the kinetic energy, but you didn't lose any momentum. That's frankly nonsensical.
To move that matter in the universe takes energy to move the matter.
It doesn't take more energy than it takes to move it at 5 miles an hour. And that's exactly how much energy the first object gave to the second object. 5 miles an hour. It gave it exactly that much.
And I can hear you now. Oh yes, it's come from this one.
Yeah, duh.
Because we've lost half of the speed, it's given it to this,
yes.
So they go off.
Yeah. It's a good answer. Damn good.
Half the speed. If now these two masses collide into the 10 pins, Gary.
So again, we're doing 10 pins for some reason. Yeah, it's making the bowling ball heavier and slower does not make it knock down more pins. And it doesn't make it knock down less. It's about how much momentum hits the pins. Momentum knocks the pins down. Nothing else.
How many pins are they going to knock over? They're going to knock over 10 pins, aren't they, Gary?
And if it was a 5 mass going at 10 velocity, how many would it knock over? And if you say 10 again, well, then you're not conceding to your kinetic energy theory.
Because it's got 10 joules. You say the momentum is the same, so that the energy is the same.
Yes. That's what I say.
10 joules of energy.
It's perfectly sensible, and you didn't debunk it at all.
10 joules of energy. There's been no loss in energy.
No, there's been half the kinetic energy's been lost. No loss of momentum. I can't believe he's this dumb. He doesn't know that there's two different equations. They make two different predictions. One prediction is that the momentum is conserved and 10 goes in and 10 comes out. The other prediction is 20 goes in and only 10 comes out. That's your prediction. Your prediction is half the energy was lost. 20 joules went in, 10 joules come out. That's your physics.
In moving this mass from left to right, where has the energy come from, Gary?
It doesn't need it. It already comes from the first object. That one had 10 joules, let's say. It's now divided the 10 joules between the two objects, so each one has 5. The 10 still exists. And that's all there is. There isn't anything else to say. The first object had a higher velocity. It now has half the velocity because it gave the other object half of its velocity. I mean, duh.
Move the mass from left to right, because at the end the energy's all there.
Amazing.
And it's all there, and it's all there, and we've moved a mass, accelerated it, moved it up to 5e for nothing. For nothing. All the
it doesn't make any sense. Yeah, that's right, for nothing, because all I have to do is push something. And I push it, I give away what I have. Something had to give away its energy. The 5 mass gave away half of its energy to the other 5 mass. It gave away half. Now they both have half. That's all.
energy's still there according to you. That we cannot move matter in the universe for nothing.
So again, where's the nothing part? It's going half the speed. It clearly wasn't free. If they were both going 10 still, well, then you'd have an argument. But they're both going 10. They're going 5. Oh, man. It just... Shit. I mean, it's amazing that he called this a complete debunk when it's so stupid.
This is what you're claiming. You've got to let this sink in, old chap. You cannot move matter without a cost of energy.
Well, he already described it. The thing here has 10 joules. The individual objects now only have 5 each. So one of them lost half of its energy. Clearly. And where is it? Well, it's in the other object. I mean, damn stupid. I mean, he could have just written it right here. 1 times 10, and then this is 1 times 5 plus 1 times 5. I mean, how could he fuck this up this badly?
Half the energy has to be missing. And that's where the kinetic energy perfectly explains it. Half the energy is missing.
Missing where? So that's again the argument. So you don't have to account for where it went. You can just miss. Just disappear. It doesn't have to be heat. It doesn't have to be movement. It doesn't have to be anything. It could just be nothing. No sign of it. It just disappeared from existing in the universe. That's not good science.
We've put in... If we kick this thing with 10 velocities and 10 joules of energy, we've paid 10 joules of energy in the transaction.
There's nothing was paid for that wasn't kept. It's like he gave it to his twin brother. So he had $10. He gave $5 to his twin brother. They both got $5. And now they move on. They have the same spending cash. Nothing changed. Your theory is that somehow half of the energy's gone.
We've got 10 joules out of our pocket and paid it to the man for the ball to go at 10V.
So there's no paying it to the man to go 10V. Again, the Newton's cradle proves that. I don't pay for it. This one has it, and then that one over there has it, and then it gives it back to this one over there, and then it gives it back to that one over there. There's no payment for a transfer. Transfers, there's no PayPal saying I'm going to steal the money. I mean, you know, PayPal is only 5% or whatever. There could be a little friction, a little bit of loss. 5%, yeah, you don't lose half the money. You have to explain. When you lose half the money, you have to explain it. You can't just say, there was something that happened that took half the energy.
We've lost the energy. We got it.
So we didn't lose any. We just transferred it, and we transferred it to a player who's staying in the game. He didn't leave the stadium. He's still right there on the field.
Back here, but we've had to give this energy.
Yeah, you did. You gave half of it to somebody who's exactly the same as you. So it's exactly the same energy. He has half, you have half. $5. $5 equals $10.
Who's giving this energy to this mass to go from left to right?
Amazing.
Because at the end it's still the same, 10 joules.
Right, I didn't lose any anywhere. I just changed whose pocket it was in. And it doesn't cost anything to put it in somebody else's pocket. And if they happen to be going the same way I'm going, well then it looks like we still have $10.
It always costs energy to move a mass.
So he says it again. It costs exactly what it costs. It doesn't, there's no fee for it. You transfer energy. I guess this is the thing. He doesn't understand. Energy is transferred from object to object to object to object to object. There's nothing else but transfers in the universe. Energy can only be transferred. That's it. There's nothing else that can happen to it.
Whether we get it back or not. This one, it's got to be accounted for, the energy. It's not coming out of the total of the final.
It's just amazing. It's obviously not coming out of it because both of them are moving in the same direction with the original energy. They're not going some other direction. They didn't leave.
Where's it come from? Kinetic energy explains it perfectly.
I don't know how it explains it perfectly. You start off with 20, you end up with 10. And there's no explanation for who took the 10 away. Where did the 10 go? Who's got the 10? Where is it?
You've lost half the energy in moving this mass.
It doesn't take 20 velocity. I don't need to bang something into something with 20 velocity to create 10 velocity. I don't have to do anything. I just transfer it again. There's no fee for transferring. Newton's cradles prove that.
Now then.
Oh, amazing.
What more can I say?
Boy, you could say it's time for you to just go away and shut up, because this was the stupidest video you've made. I mean, they've all been stupid, but this was incredibly stupid. What an insane waste of time. I can't, comments. I can't believe somebody's going to defend this absolute nonsense. Got an allergy. Alright, let's try reading some of this crap. The objects are doing work by grabbing each other. They create friction, absorb the impact. No slide or bounce. This work creates heat in the object. So this is the cliche answer that half the energy of the object was radiated as some sort of waste energy. There's absolutely zero evidence of that in any of the experiments, and you'd still have to explain how it did that. You made heat without using any of the momentum. It's like saying the bowling ball knocked down the pins and didn't slow down. It just doesn't make any sense. Okay, and that's why some KE is lost. So again, it's not some, it's half. At least half. More than half. Again, just nonsense. Another way to look at it is to think about it in reverse. If you have two objects traveling 5v and you want to lift one object up to stop it while doubling the velocity, so this all makes great sense, and you want to lift one object up, what are you talking about lifting one object up for? There's nothing in this analogy with moving carts about anything lifting. Okay. And stop it while doubling the velocity of the other object. You have to put some energy into the system and change the movement of those objects. So what? That's removing, that's separating things. Things combine in nature easy. Things separate in nature really hard. Okay, so that's just cheating the argument. That's like saying it's harder to, that it's, the fact that it's easier for me to drop something into gravity than to pull something up out of gravity. Duh. Okay. Conversely, when you drop an object on top of the 10V object, some energy is lost. So again, you keep saying it's lost. There's no evidence that it's lost. There's no evidence of it going anywhere. There's no evidence of more heat. There's no heat signature. There's no evidence of it at all ever provided. Ever. There's no form of denting. There's no form of sparks. There's no form of anything that could account for half the energy. It's just made up. This is all physics has become. It's just make this shit up. Pretend you have some evidence that that took place when there's zero evidence it took place. Of course, it didn't disappear. Well, where is it then? It's just turned into heat. Prove it. Demonstrate it. You don't have a single experiment in the annals of physics that demonstrate that to be true. And every example you see, you understand, you can just look at the experiment and say there's a lot of energy in the object moving. That much heat would be realized somewhere. It would be noticeable. Kinetic energy of vibrating particles. So again, more crap, which does not consume momentum. How does it not consume momentum? If a bowling ball goes down the alley and it bounces, it's going to move slower. It's going to lose velocity to the friction. You can't create heat. Friction creates heat. You can't create heat without consuming momentum. Oh, what liars. And then Gosling, this idiot. No, I thought this might be more difficult than it should be. What the fuck? Forget friction and assume a perfect assimilation of masses with no loss of energy. It's sharing the energy with another object going exactly the same direction. What the fuck are you talking about? The point is, Gary is saying the second mass can be moved without any energy needed at all. Again, it's just so retarded. It went from going 10 miles an hour to going 5 miles an hour. That's called losing energy. Perhaps you need to watch his video to fully understand his argument. Apparently you don't understand it, you fucking idiot. Oh, half the K is lost in moving the second mass. Every single time you transfer energy between a light object and a heavy object, or a heavy object and a light object, you either have to destroy momentum or you have to destroy kinetic energy. There's no alternative. Oh, these people are so stupid. So this Sean Walker guy says absolutely nothing. There's no kinetic energy theory here. Doesn't mean anything. He's not pointing out, well, yeah, you lose half the kinetic energy. Do you agree that Bob's theory requires matter to be moved for free? Bob? Who's Bob? Oh, I don't even know what the fuck the point is. Do you agree with my conclusion about where the energy comes from to move the second mass? Again, how can he say something this stupid? Leska. But why there isn't such energy cost in elastic collisions, like when a two-mass object hits a one-mass object? Yeah, and there's no energy cost, and you get free momentum. Anyway, elastic collisions tend to involve, oh, well, this is the crazy green idiot. harder and denser objects. Again, no, not necessarily. So the wave speed within them often, upon collision, will be faster, and the reflected and refracted waves will be more opportunistic to pile up with each other and exit back. So now he's talking about a reflection being a reflection, when no, the physics you have to defend says it doesn't reflect. It actually goes into the object. That a rubber ball hits a brick wall and bounces back, it put twice as much momentum into the wall. That's your theory. All right, into colliding objects, blah, 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 blah. This will result in there being a larger net reaction on the collider from the target and less absorption into the original target and less wasted motion. So again, it's obviously, there's obviously no wasted motion when you throw 100 in and you get 300 out. Yeah, that's not waste. Oh, this is so stupid. Between $40 and $80 per hour to hire a legitimate physicist on Upwork. Yeah, and guess what? And they won't allow you to record them. So you have to pay for them, and they won't let you record them. 1 hour, watch his video. Another hour to record a rebuttal. The series of 5-minute videos. I don't understand it. It takes you an hour to watch a 5-minute video? I don't understand. 1 hour to watch his video, another hour to record a rebuttal. The series of 5-minute videos. We'll just pick one of the 5-minute videos. Might be worth it if we all chip in the money. Isn't that hilarious? So they think a physicist is going to be able to answer these questions. They're not going to answer them. There's no answer except you're right. That's the answer to most of the videos. I'm right about linear friction. I'm right about gravity being a time-dependent force. I'm right about rolling. That's the linear friction. I'm right about the Deschardelet clay experiment being bullshit. They're just amazing. These people are just amazing. So none of them are really on the subject of this video. Does the video play okay for you? It keeps sticking for me. So his own video doesn't work. Alright, so let's finish this up. Let's see, I don't know where exactly I left off, but does the video keep sticking for me? Yes, it works. Okay, Gary should pay that. It's a steal compared to what he's been offering. So this is Piro saying this nonsense. Yeah, clearly, I've already done this twice. Okay, twice I found places that, pay them for it was $50 for a half hour. And one of them was run by Sabine Hassenfelder before she became famous. She was running some little racket, and yeah, as soon as I asked, can I record? No. So no deal. I was thinking less physicist and more psychologist. So it's the Ian Gosling. So he's not provoking an argument. Yeah, no, not at all. Whatever. I mean, just bullshit, bullshit, bullshit. So then he asked Piro, do you agree with the point about the missing energy? There's always going to be missing. You can't not miss it. So, again, so this is this simple, right? I find two $5 bills on the street. And let's say I have a wife. And we agree to meet at the store door at Walmart or something. And so I have my two $5 bills I found. I show up at the door, I give her one of the $5 bills, and we both walk in to go shopping. Now we both still have the same amount of money, $10. I mean, what's complicated? There's nothing complicated. The momentum is conserved. Didn't lose any of the money. The kinetic energy is what disappeared. Somehow, by merely transferring half my velocity, I gave away half the kinetic energy, just disappeared. Because we're sharing it, then it just disappears. So I start off with $20 and now we only have 10. So I had 4 5s and now I only have 2 5s. That's the kinetic energy theory. It's just too stupid. I remember when you made this point before, and I think it does make sense. That's hilarious. What makes sense? He doesn't say anything. How could you possibly make sense out of this video? What makes sense? He says it takes more than, let's say, again, the Newton's cradle. It somehow takes more energy for me to transfer the energy from this ball to the end ball. Requires me to use twice as much energy somehow. Somehow I have to use twice as much energy to do that. I mean, obviously I don't have to. It's just too stupid. Okay. But it's hard to get my head around. What's you give away money. There's no other way to get it. You either have to steal it from somebody or they have to give it to you. But that's it. That's how energy works. You either take it from something or something gives it to you. But it has to happen that way. The energy has to be somewhere. It's like apples don't poof into your hand. They have to grow in the tree. You know, there's just those are the rules. The energy has to be somewhere for you to take it. You can't have it unless something else doesn't have it. I'm still thinking this over from the first time. Amazing. Have you thought over the 25 times the fuel to go 5 times faster? Have you thought that one over? I mean, I could just keep making the numbers sillier and sillier. Shit. Anyway, 50 times the fuel to go 10 times as fast? Something like that, right? It's probably worse than that. I mean, just the numbers get so silly. Alright, so anyway, so that's the video. God, I just can't stand this planet. Just asshole after asshole after asshole. Just all over the place. Anyway, so that's his complete debunk. What did he debunk? He debunked nothing. Way over advertised once again. Shit. So, till the next time and such, I guess we'll call that a video. I could get rid of stuff. And, yeah. It is just kind of a dank and depressing reality we must exist in. Yeah. Okay, till the next time and such.